Okay, so of course, the most important stuff that's going to happen will be tomorrow. Your written test one is going to be tomorrow, but the start time will be a little bit different from your programming test. I'll get to you. Give me one moment. So the start time is a little bit different, so please do check the PDF guide to see exactly when you should really show up, like last time. But this time, make sure you bring your mobile phone. You're going to need your dual mobile verification. And then practice questions are there, and I also made available a past recording session. If you want to go over the practice question one by one, feel free to do that. Just check the e-class for link in one of the announcements. And then what we're going to cover today is not going to be on the test tomorrow, but since you already made your visit, why don't you pay attention, right? It's going to be important stuff. How about that? Patricia, you have a question? For the lab grades, yeah, sure. So as long as you kind of make your submission actually before the deadline, you can assume that you actually get a full marks for that. So normally I wouldn't really make them like on the e-post until maybe towards the end of the semester. But I can assume you got full marks as long as you actually make your submission before the deadline. If you really want to verify, you can feel free to drop by office hour. We can verify that.
So is it not tested based off of JUnit?
No, for your labs, it's really about as long as you submit your best attempt before the deadline, you get full marks. It's really for participation. Yeah, what I really care is how you perform in the test, right? Okay, good. All right. And then, so your programming test 0 and 1, I also released the marks and feedback. If you have any concern, if you want to worry about if you should really submit a regrading request, come and then we can talk, right? You can approach me after class. I'm always happy to stay a little bit longer or just drop by office hour. I do apologize, I couldn't make it yesterday, but I'll be sure I'm there tomorrow. So we can definitely talk if you want to. All right, and then your lab number 3, right? Just make sure, keep up the pace for the course. And the lab number 4 and 5 are the remaining 2 labs for the course. And I will make sure I release in time. And then I think the plan will be today and also Thursday, we're going to finish most of the equals method. I'm hoping that I can finish the lecture so we can start you fresh next Tuesday for inheritance. That will be the plan. All right. Let's now do a quick recap about what we said last time from last Thursday. All right. So last time, we actually talked about one more example about the call by value, so you can review it. It's basically following the same principle. Whenever you have a method call, like a register and register all, you got one instance of the call by value. Just make sure you understand how the parameter is initialized using the arguments, not the other way around. Okay, you can review the recordings there. So take a look. And then, most important page, we're going to use that for many times today. It's really about whenever you have a method call, specifically for now, let's focus on the equals method. If you have a method call like this, we know that X is the context object, Y is the argument value. Now we want to determine which version of the equals method is going to be called. In this case, you can disregard completely Y right here. Only look at the context object X, and then look at its dynamic type. And today, a little bit, maybe about 15 or 20 minutes, I'm going to talk about some foundation between static type and dynamic type. But for now, think about dynamic type is really the title of the box of the objects, right? So let's say X, at this point of executing this line, X is pointing to an object of that particular type. It's called dynamic type. And I'll show you in the code as well. And how do you actually trace the dynamic type? Trace the name of the constructor. I'll show to you, right? Just to brush up. So once you find out the dynamic type for the context object, you're going to go into that dynamic type and see if the equals method is overridden. If it is overridden, that's the version to call. If it is not overridden, you're going to call the default version from the object class. Guys, any question about this page here? It is so foundational. Right? If there's any part that's not clear, maybe reach out to me. Right? This page is so important. Okay. And then we spoke about, I think, just visualizing, right, about X, right? X can be either pointing to point V1, it can be pointing to point V2, right? So depending on which timing you're calling the equals method. And then we talk about the default version. So if you look at the context object here for the equals method, you got P1 and also P2, right? These are the only two. And the way to figure out dynamic type is to look at which new keyword, well, every new keyword has to be followed by the constructor name. The constructor name tells you about which type of object it is going to create using that constructor. So if you look at the constructor name, it's going to tell you what a dynamic type is. And today, we're going to broaden the context a little bit. So this part here is about dynamic type. And this part here, what we declare P1, P2, P3 to be, this is something called declared type or static type. That's something we also have to clarify as well. All right, we'll get there. And then, so here for P1, so P1 and also P2, right? Because the context object is simply just P1. And P1 has a dynamic type, point V1. In that case, we're going to call the version from point V1. And point V1 has no explicit overriding of the equals. In that way, just call the inherited version, default version from objects. All right? And specifically, you want to revisit just about line number 9 over here. When you have P1 being point V1, and S being a string, you're basically comparing two objects of different types. However, when you call equals method, the argument here can be anything, any objects. By definition, anything is an object in Java. So in that case, we can pass a string. And this one here will just boil down into P1 equals S, comparing their address. In this way, since they are different objects, they'll have different addresses. And we also dive a little bit deeper into if you write out P1 equals S just by yourself, in that way you cannot do it explicitly. But if you kind of call the equals method, and then it might boil down of doing this implicitly, that's okay, right? You're not doing that directly yourself. I wouldn't worry too much about casting over here, okay? That might just confuse everybody else, yeah. But it's not recommended anyway. Yeah, because you're somehow just kind of forcing things to work just by playing with the compiler. I wouldn't recommend it. Because every time you do typecast, you might run into the risk of like a class cast exception, which we'll speak about later. Okay, good. Question?
What happens when you cast an object into a specific class?
Let me talk about typecast. Well, we have a page for that, so let's wait for that. It's coming. Yeah, definitely we'll talk about a little bit about typecast today, so you will see. All right, and then over here, we talk about call by value, right? Just remember we got argument P3 over here, we got parameter obj here, and we are making the method call. That means obj, the parameter, is pointing to the same object as P3, the argument, right? We're copying the address. That's call by value, all right? We're going to see call by value quite often today when we talk about different phases of the overridden version of the equals. All right, so we talked, second part of last Thursday, we went over about the short circuit evaluation, right? There's a whole discussion over there. So please revisit for your test tomorrow. That one's covered last week. And just, you got to revisit the truth table right here. And also revisit the evaluation using short circuit, the principle of short circuit evaluation. You're going to go from left to right and also left to right. And then the way to understand this, I'll put it here. Okay, right here. Let's say if you use the AND operator versus using the OR operator, you can think about some expression on the right-hand side. It's meant to be protected. Protected in the sense that you don't really want to evaluate it if that one might trigger division by 0, array index out of bound, or null pointer exception. You somehow want to protect them in general. And in the case of AND operator, the Boolean condition we say stay here is so-called guard condition, meaning that if the guard condition is true, that means it's passed. In that way, we can pass through to evaluating whatever expression it is. There's no risk of doing it. So the guard condition here must be correct, right? So we kind of saw the example. We'll see a little bit more this week, either this week or maybe next week as well. On the other hand, if you use the OR operator here, so the condition you specify here is so-called error condition. Think about guarding condition and error condition. They are simply the logical negation of each other because you can see not equal versus equal, right? So they're kind of negation of each other. So the way to interpret this condition here for OR, think about it's more like an error condition. What does that mean? If the error condition is true, that means there might be some error on the right-hand side. So we simply skip the evaluation of the right-hand side, right? So just always remember about the order of evaluation and under what circumstances will you actually skip the evaluation of the right-hand side operand. So it's a different condition for AND versus OR. All right, any question about short circuit evaluation? All right. And then you can definitely revisit, also look at the practice question. I think one of them actually talk about that ampersand vertical bar. And then that's the example we did for short circuit evaluation. And here, array indexing is something we would like to protect. Whatever you want to protect ought to appear on the rightmost. Okay? So that means the correct way of structuring that should be, you got basically two guarding condition followed by the rightmost array indexing. Okay? How you order G1 and G2 doesn't really matter, but you have to make sure you check all the guarding condition before the very last expression. All right. Question? Good. All right. And then, yeah, some self-explain example for you to also trace. Try to trace this particular input and see what happened, right? You will see a little bit more about how things work. All right. Let's now move on to equals method. Just before I move on, guys, any questions? Anything you want me to clarify? Today could be a little bit intense because we're going to talk about phase 1, 2, and 3 and briefly touch upon the essence for phase number 4. And we also have to explain static type, dynamic type, and also typecasting in an intuitive sense. Okay, let's now move on. So now we switch the context to the class called point V2 right here. So point V2 has explicitly overridden the equals method, right? So just as a very quick overview, right? So for the equals method, you will see line 1, 2, and 3. These first three phases are rather standard. So that's what usually when people write the equals method, these three lines are almost basically the same, but they're for a reason. I'll explain line by line. And then you also got phase number 4. Okay, for phase number 4, we get to spend a little bit more time. Okay, let's see phase by phase. Phase number 1. Let's look at the line. We say the equals method is supposed to return Boolean, right? True if, well, let me just write it down. How about this? When I write P1 dot equals P2, so there are only two outcomes. Either return true or it might return false. Return true if P1 and P2 are equal. Return false if they are not equal, right? Conceptually, very clean, very clear. And then, let's now look at the first line. We're saying that if this equals obj, you can see the operator we are using is the address operator because we're talking about reference variable because primitive variable cannot call the equals method, right? So now it's reference variable. If this and obj happen to be the same objects, then they are just equal by default, all right? I'll write down this interpretation here. So this one line here is really just trying to say something here. So we're basically saying if the context objects and parameter obj are the same objects with the same address, then they are equal. Okay? And let's visualize what's happening here. So we're basically saying there is some objects in the memory right here. And if this Boolean condition here, this and obj are the same, that means this right here and obj right here point to the same objects, right? And let's bring a little bit more into the context. What's really this and what's really obj, right? Let's take this particular method call, for example, right? P1 over here is the context objects, right? So this and P1 really mean the same thing, okay? So P1 over here is the context objects, which is the this that we kind of refer to in the method body. On the other hand, you can see the P2 over here is the arguments. And because of call by value, we have obj is initialized to be P2. So that means P2 is also pointing to the same objects, right? So whenever you're trying to make a method call for equals, always remember you always got these kind of 4 variables, pointing to objects. Okay. In this case, we got P1 and this context objects, P2 and OBJ. They mean the arguments and also parameter. Okay. I'll write down one more. So think about the OBJ here is the param. And the P2 over here is the arguments. Right? They point to the same objects. Okay? So now one more point. So when this equals OBJ, when this equals OBJ, if they simply point to the same objects, an object should be equal to itself, obviously. Right? Just return true. Trivially. All right? So that's the first phase. And we're going to do one example. Any questions? All right. The first line just about definition, right? So of course I'm going to do some tracing together with you. But just got to understand the first one here is saying, when you say P1 dot equals P2, it will just return true if P1 and P2 happen to be the same objects. They have the same address. Let's do one example. All right. So simple one, and then I'll give you another one. The first one here is very trivial because you can see what you have is this. Okay, let's try to trace this. So we got P1 over here. That is the context objects. And also we got P1 over here. Just happen to be the same. That one is the arguments. Right? And then when we step into the equals method, right here, right? Because we know the dynamic type. So here the context object is P1. So remember the principle. We have to look at P2. And beg your pardon. It's a P1 is a context object. So look at P1, it has the dynamic type of point V2. How do we know? You can see P1 here, we have the dynamic type, point V2, right? So this is the dynamic type. So that means we've got to go to the dynamic type for P1, and which is point V2. And then it has an explicitly overridden method. That's the one to be called. All right. And then when we call that one there, let's see what's going to happen. Okay. So first of all, P1 itself is the this. So whenever you see this, for example, over here, so this is really just P1, okay, when we are tracing it. What about OBJ? The OBJ over here is the parameter. And we have call by value, OBJ equals arguments P1. So OBJ point to the same as P1. So now when we actually compare that, this equals OBJ. This and OBJ point to the same objects, so we go to that branch, right? So these two are the same objects, so just return true. Okay. So let me write down here, return true, because P1 and P1 are the same objects, trivially. All right. Let me give you one more example, right? This one here seems very, very easy because you got P1 and P1 just happen to be the same. All right? Why don't we say the following? Let me say I have another line of code. If I say P4, okay, another example. If I say P4 is simply assigned to P3, let me do that. All right? As soon as I do this, I'm actually going to have P4 pointing to P3. Right? That's something you're supposed to do tomorrow for the written test, right? Tracing. And now let's consider method call. If I say P3 dot equals P4, right? Now let's consider this. P3 is right here. It is the this, right? Context objects. And also P4 is the arguments, and we know that OBJ is going to be initialized to P4, call by value, right? So obj is also going to point to wherever P4 is pointing to. So this is the parameter. And don't forget, P4 is the arguments. And when we try to execute this line here, this and obj, this and also obj point to the same objects. True, right? So this is true and return true. Okay, let me say this line here. Also return true because P4 and P3 are the same objects. P3 and P4 are the same objects. All right, so that's about phase one, right? We talk about how that line is declared, it means defined, and also we did one tracing example. Okay? Any question about this one? All right. Phase number two. Notice that phase number two is right here. And there is one line before that, which is phase number one. We know that at the runtime, when we execute Java method, it's going to go one by one line after another. The fact that we are able to reach this line and try to check this phase number two condition means that we didn't actually return true. Agree? Hello? Can you take off your headset? Please. Thank you. All right, so here, you can see that if we are able to actually reach this line over here, that means this branch over here evaluated false. We didn't actually return true. Otherwise, we would have returned already. We didn't even have a chance to really reach that line. Okay, let's write it down. It's very important because when you actually get to a later phases, all the earlier phases wouldn't have already returned. So that means you have to understand what the conditions are. All right, let's now take a look. So let me write down. Reaching this line. Means, okay, let's think logically. That would mean this expression here should evaluate to false. Not the case, right? So that means this is not equal to obj. That simply means this and obj, they are not the same objects. If they were the same objects, we would have returned true. So now, if this and obj, they are different objects, we kind of bother to go to later phases to find out. Maybe they are not the same objects, maybe their contents are the same. All right, that's the logic here. Let's now visualize right away, okay? So what we have is, let's say we got this, and also we got obj, right? These two. So we got this, and also we got obj. They simply point to different objects right here. Oh, let me use different color. They simply point to different objects. Or potentially, maybe, well, I'll get there, okay? Now, let's look at the second line. Phase number two. We're saying this. At this point, if obj is null, then there's no way this and obj equal to each other, right? Because we return false right away. All right? To understand the logic of this, I would suggest we try to extend this phase a little bit, just to make a little bit more case analysis. Okay? Somehow, when we say obj equals null, but we can subdivide what's going to happen inside to see more clearly. Okay, I'll show you. Okay? So what I would do is I'm just going to extend this a bit. So let me say, let me put this, right? Star. I'm going to show you some alternative version of phase number two. So what we have is, first of all, if obj equals null, let's keep that. Equals null. Okay, keep that one. And then inside, Rather than returning false directly, let's think about, because there are only two variables we care in the equals method. We only care about this, the context object, and obj, the parameter. We already talked about obj. Let's talk about this. If I subdivide that into if this equals null, otherwise something, okay? Okay. In this case, if this is equal to null and obj is equal to null, we know that null equals null, true, right? If you compare these two addresses, that part there should return true. Okay, logically. If we get to the else part, that would mean this part here is not the case. So we have this not equal to null. Right? Can we get to the else part? Now, if we consider obj is null, but this is not equal to null. If you compare the addresses between something that's not null and something that's null, should be false. Return false. Right? Let me box this alternative version of phase number 2. Right? This one here somehow shows more complete case analysis. We're saying that assuming that obj is already equal to null, we want to further check if this is actually equal to null or not equal to null, and then return accordingly. Okay? This part over here is the actual result right here. So now the question is, to really show understanding, we want to know why this longer alternative version that seems to be more complete, why is it not included as a standard, but why just a one-line version? That's the question. Let me say that again, okay? I really want you guys to think about. Guys, I want to make the question very clear. Think about it, okay? This is the one-line version for equals method. That's a standard, just one line. We only specify obj's condition, not this, and then return false, right? That's a one-line version. And this longer version over here, where we kind of consider not just obj, but also this, which may be either null or not null, right? And then we try to, basically, this is the additional case. Think about this. Somehow, this is the additional case that we have added. We're only considering if this is equal to null. But now the question is, why is this longer version that seems to make more sense? Why is it not included as a standard? Go ahead.
Oh, because from phase 1, we're assuming that this and obj are different.
Are different? Sure, but what does it say about this? We just know that they are different objects, right? Oh, I know what you mean. Okay, that's a good point. I like it. Okay, yeah. Hold it. Yeah, I'll let you. Okay, so I think your fellow student made a very good point. From phase number 1, we know this. They are not the same objects. And given that obj is equal to null, that means this cannot be null. That's one way to see. Yes, I agree. Yes, very good. I like it. But there's another reason. Think more about from runtime execution point of view. Go ahead.
This can never be null.
This can never be null. How come?
Because if it's null, then how are you inside the equal? Because didn't you use this dot equals to call equals?
What would have you got already? Mm-hmm. Is that something you're thinking? Good. Very good. All right. Exactly right. So guys, it's very important, actually, aside for you to see. All right. I'll write it down here. So this part here, that seems to be just adding some case to make the case analysis complete. This code here is what we call unreachable. Because if this or null, then a null pointer exception would have already occur. You know, for example, let's say if I say P1 dot equals P2. In this case, if P1 itself, which is this, if that one there happens to be null, in that way, we don't even get a chance to step into the equals. We would have got null pointer exception. Okay, so I like both explanations that you guys just talk about. All right, that's good. So that means null pointer exception. Okay, this is kind of interesting. Just as an aside, you know, these days people like to use ChatGPT, DeepSeek, you know, like a generative AI tool to generate code for your solution. In some published literature, have you heard about the term hallucination about AI? Right? Unreachable code is actually one of the hallucinations that might be generated in your AI code. So AI might generate some working solution, yes, but the solution may be more complicated than necessary. They might generate some block of code that may never be reachable logically. So just want to put for your knowledge. Don't worry, it's not in the exam or test, right? Just for your knowledge. Okay. All right. Anyway, so that's good. So that's the phase number 2. Okay, right here. Null pointer exception and also this Boolean condition. You know, I think you guys are good for today. All right, so let's now talk about example quickly. Okay, so for this one here, let's now check it. So we know very well the P1 over here is this, right? So P1 right here has a dynamic type point V2. All right, so we're going to call this version here, right? We've done this many times, so I'll go a little bit quicker. So we got P1 that equals null. In that way, you can think about this is pointing to P1. And also OBJ over here, call by value, OBJ will be pointing to just null. Right? And let's now trace it. Phase number 1. We got this here. Okay, let me put it in this way. Okay? Let me try to use a laser pointer. This equals OBJ. This and OBJ, compare these two, they are not equal, right? So that means this part over here is false. So you don't get a chance to return true right away. And then you go to phase number 2. And then you can see that OBJ equals null. And then we return false right away. Okay? Return false because P1 is not null, but OBJ is null. Okay, very important. Phase number 2. You can think about phase number 1 and 2 as somehow dealing with edge cases. One edge case when the two objects are just the same objects in the memory. They are the same, just true, trivially. Or if you're simply comparing something that's not null with something that's null, they're also not equal. No way, right? Just talk about two edge cases. All right, guys, any questions? Okay, all right. And let's now talk about phase number 3. Okay, for phase number 3, right here. Okay, let me do a little bit preview quickly, and then we'll see. Okay, so for phase number 3, if you look at the definition, you will see this .get class and also obj.get class. All right, just verbally, I'll write it down a little bit later. Get class and get class over here is some like a predefined method in Java I can always call on some reference variable. Okay, get class and get class. What that returns is something called dynamic type of the objects. So now let's now do some tutorial page, like an example, to really go through about the different concept over here. Okay. Let's now, first of all, let's take a look at this. Okay. I'm going to guide you through, so let's go very slowly here. Let's start with static type. Static type, right here. So static type here, sometimes we also call it the declared type of a variable. Declared type. Okay. So for example, you can think about for O1 and O2, right? You can think about for these two over here, they have the different static types, C1 and C2. And also for O3 over here, it has also another different static type right here. Okay, I'll put a table aside. Think about we have a table here just to compare. So let's first of all put variable here, in which case we got O1, O2, and also O3. And we talk about static type. Okay, just declare type. O1, C1. O2, C2. O3, objects. Remember, object is a class. So any class can be the static type for some variable. All right? What's so important about declare type or static type? Number one, static type can never be changed. It's always fixed. Once you declare a variable of certain type, it's fixed. Okay? You cannot change it. I know in some other programming language, you may not even need a type for variable, but it's not the case for Java, right? For we call that a statically type, like a strongly type programming language, but Java is one of them. Okay? So once you declare the type for O1, O2, and O3, you can never change it, never ever. Okay? In some ways, it's simple, right? Because you cannot change it. What is so important about the static type? Once you know about the static type for a variable, that determines the range of methods and attributes you can invoke on that particular reference variable. I'll write it down. It determines the range of methods and attributes that can be invoked on that reference variable. I'll repeat, okay, just in case you cannot read my writing. So the static type over here determines the range of methods and attributes that can be invoked on that reference variable. All right, let's see example. Before that, let me do one visualization here, okay? Because we actually got C1, C2, and also we got objects, right? And our assumption here is this. Let's say in the object class, we only care about the equals method. Let's say you can care about toString, hash code, that's okay. Similar reasoning. But let's say just the equals method. And in class C1, we have a method called M1, nothing else. And in class C2, we got a method called M2, nothing else. So C1 does not declare M2. And also C2 does not declare M1, right? You can see that, right? Let's now visualize what's happening here. Remember we said earlier, every class by definition will be the child class of objects. Let's visualize that relationship right here. And there's a very important concept I'm going to talk about too before we move back. So let's say we got object class, and then we got two child classes. So we got C1 and also C2. C1 and C2. And we talk about something called expectation. Expectation of a type or a class is really just about the range of methods or attributes callable on that type. Let's see. In the case of objects, we know that we have the equals method. That's all we care. Okay, equals. In C1 and C2, we look at what's really explicitly declared over there. We got M1 in C1, we got M2 in C2. Let's write it down separately. So we got M1 and also M2. Now, inheritance also tells you that anything or any expectation that belongs to your parents, they will be inherited and accumulated as part of your expectation. So that means since equals is an expectation for objects, you can call equals on object, right? So that means the equals method will be inherited to both child classes. So to the complete expectation for C1 should also include equals method. And this one here should also include equals method. Right? We're going to do a little bit more exercise like this later. So the important thing is, whenever you have inheritance, one of the usefulness about it is you can accumulate code from parent classes. Okay? So let me say it again. Expectation for each class is about a range of methods you can call on that particular type. For objects, it's really the simplest one, just the equals method. And the equals method will be inherited to any class you create, which is going to include C1 and C2. So equals is part of the expectation by default because of inheritance. And then for M1 versus M2, they are just the methods explicitly defined in these two classes, right? So let's write it down. So we got expectation. For O3, the static type is objects. So we only got equals. And equals will be inherited to both classes right here, right? You can see for O1 and O2, because they got C1 and C2, they are child classes of objects. So equals should be included by default. And then in addition, C1 we have M1, C2 we have M2. So here we got M1, also M2. All right, so important. We'll see exactly how the concept about expectation can impact the way we're going to trace the code. We'll see. Okay. Okay, let's go over two more definitions and we'll take a short break, and then we'll do tracing after the break. So dynamic type is right here. So dynamic type by definition is what we call runtime type. Runtime, the type at the runtime. And it might change, may be changed. So you can see the contrast between static and dynamic. Static type never changes. Dynamic type changes all the time, as you wish. Okay? And then, what about runtime type? Okay? This corresponds to the one-page principle that we spoke about. We can recap in the beginning of today. So that one there, so runtime type or dynamic type determines the version of method that's called. Okay, we'll see that in a moment. For example, for equals method, depends on whether the dynamic type is point v1 or point v2. Right? You might call different version of the equals method. Okay, just definition here. Okay, one more thing about typecasting. Typecasting will just give you some intuitive definition, but we're going to trace the code to see exactly how that works. Okay, the typecasting over here goes like this. Some very common misconception about typecasting is, if I try to cast one variable to another type, am I modifying that particular variable I'm trying to cast? The answer is no, you're not really doing it. Okay? So always remember, whenever you're doing some typecasting, all you do is you're creating a copy of the address. And then that address there has a different associated expectation, like a different static type. So always creates a new copy of address with a different static type. Okay, we'll visualize this. We'll make it more concrete a little bit later. Just remember, whenever you talk about typecasting, you're not really modifying anything. You're just creating one copy or creating one alias. But that alias there has a different static type. Okay. All right, I would suggest we take a very short break, taking attendance. And after the break, we're going to trace all these code by applying what we just learned. Okay, you can get your iClicker ready. Very quick tip for tomorrow. Lots of tracing to be done. Make sure you bring your sketch paper, number one. Make sure you know how to visualize objects and trace aliasing. All right, very important. I cannot say more. Okay, and then There was a very short session last Saturday, about 30 minutes or so, but I'm going to post it today. I'll make sure I do that. This is nice and sweet. I think your fellow student asked some nice question. You can take a look, fast forward, whatever you like, right? I'm going to post it maybe once I go back to my office after class. So tomorrow you want to make sure, focus on definitely tracing, short circuit evaluation, make sure you review it. And then lab 0, we talk about different concepts like a products, store, things like that. Get yourself familiar about how those basic methods are implemented. So for example, if I say, assume the app product method is implemented correctly. So what do I really mean by that being implemented correctly, right? So you want to make sure you're familiar with the lab itself, all right? And then, yeah, just get yourself ready to do tracing and then do some reasoning, right? It's a different kind of a format for assessment. So that's the first one. Okay. But if you got more questions, approach me after class. More than happy to answer. All right. All right, so now let's go back to right here. All right. Let's now try to trace all these lines of code. So I would say, as far as the equals method lecture is concerned, understanding just this fragment of code should be enough for surviving, just for this part. Because to really see more thorough definition for the static type, dynamic type, we got to wait until inheritance, okay? Which is going to come very soon anyway. All right, let's do it. First of all, let's now look at here. So we got 3 variable declaration. So we got C101, C202, and also object 03, right? We know about their static types, which determines about their expectation, all right? Let's now trace. And whenever you see new C1 and new C2, right? So these are the dynamic type, right? Let me just make a note, right? So these are the dynamic type, okay? O1 and O2. So O1 points to some C1 objects right here. Oh, you know what? Let me do this. And also O2 points to another objects, right? Let me use different color to kind of show to you. That might be a little bit better, okay? First of all, let's talk about dynamic type. We got C1 and C2. So I put C1 here, I put C2 over here. Also, declared type or static type, C1 and C2. This is not strictly necessary at this point because up to now, we have almost always seen the static type on the left and the dynamic type on the right are just the same. But we're going to see O3 is going to be different. We'll see, right? So I would suggest when they are different, you may also want to put the static type alongside of the variable just to remind yourself what its declared type was, right? It's very important. So what I will do is C1 and C2, right? C1 and C2. And then I got object O3. So I got O3 and then static type objects. Okay, good for now. And then let's now answer some questions, okay? Before that, let me give you some general principle here as well, okay? I should have some blank page, yeah. So we're gonna see static type and dynamic type a lot. So here is the principle, okay? Given a line of method call, let's say context object obj dot m. Okay? There are 2 basic questions we can ask. Question 1. Does this line compile? Does it compile? Question 1. All right? And then question 2. If it compiles, we execute it. And then we're going to ask which version of the method m may be called. Let's say m might be equals method. In that case, which version do we call? Okay. So if it compiles, which version of m is called? Sometimes you might have only one version. For example, M1 and M2, as we saw in the example, there's only one definition, just one version, but at least one. So we want to know which version. All right, so now here's the principle. Whenever you talk about compilation, okay, you only look at the static type of the context objects, in this case, obj. Only look at the static type. On the other hand, when you want to talk about which version at the runtime is going to be called, look at the dynamic type of the context objects. Okay, let me summarize. Whenever the question is about compilation, you only have to worry about static type. There's no runtime. And whenever you talk about which version or runtime behavior, what's going to be execution behavior, what's going to be the behavior during the execution, only look at dynamic type. All right. Having this in mind, now, guys, I want you to look at these 4 lines. Let me say 1, 2, 3, and 4. Can you tell me which line or lines do not compile? And since I'm talking about compilation, right, you only look at static type. Only look at the static type for O1 and O2, the context objects. And based on that static type, we want to determine whether each line of method call is going to compile. Any thoughts? If no, I can go over a solution. Go ahead first. Let's start one by one. Which one does not compile? Okay. Uh-huh. Okay, very good. Okay, so let me just repeat what your fellow student said. O1 over here has the static type C1. O2 over here has the static type C2, right? Declare type. And then all you ask would be whether or not M2 is defined in C1. Is M2 part of the expectation for C1? No. You only got M1 and equals. There's no M2. So this one here does not compile. So this one here does not compile. Similarly, this one here, O2 has the static type C2. C2 has the expectation M2 and equals, which does not include M1. Also, it does not compile. All right? And the other two compile. All right? It's a very, very important first detail to understand. Whenever you see a method call, and you first want to ask if the method call will even compile. To see that, look at the static type for the context objects. All right? So now you can simply say, just for this one here, you can say because N2 is not an expectation of O1's static type, which we know is C1. All right, so that's more like a justification. All right. And then let's now do O3. All right, we already declared O3 here. So let me say one more thing here. Okay, there's certain assumption we are making, right? But to really explain that assumption, let's delay until we talk about inheritance. Okay, let me write it down. So if the declare type happen to be objects, let me put it here. If I got my OBJ, there are two instances, two occasions. Let's say we got the static type objects and also the static type objects, right? First of all, we know that object here is the parents of every class. That's what we know from before. That one is the parents of every class, right? Accordingly, on the right-hand side, typically there are two things we can put. Either we can say some new, and then we say the constructor from some class. For example, I might put, for example, let's say if this happened to be point v1, I just say point v1, right? That's what we're used to. But now I'm saying that there's a special case. What if the declare type here is objects? So now here's a rule. The some class over here can be anything, any class you like. all right? This one here can be any class. That means when the static type is objects, dynamic type can be anything. That is a rule for now. We will explain a little bit later, all right? Second one, if I try to do some variable reassignments, if I say obj2, all right? This one here, follow a similar logic here. So here we're saying that obj2, the declare type of obj2 can be also anything. Can be any class. There's no restriction, but not the other way around. All right? Having these two rules in mind, let's now do the following. All right? Now, if you look at just this line here. Okay, let me say, how about this line here? Okay, right here. We say O3 is equal to O1. Right? You can see we are applying that rule. O3 has the static type objects. O1 has the static type C1. That's okay, because O3 has a special static type objects. So O1 doesn't really matter, can be anything. Okay? How do we visualize this change? Is just copy the address. So what we're doing is, so this one here, O3 is assigned to O1. O3 is not just going to point to the same objects. All right? Now, O3 dynamically is now pointing to C1. So after this one here, so after this line here, dynamic type of O3 is C1, because C1 is right here. And I want us to consider one line of method call right here. I'm going to highlight it right here. Let's consider this method call. Thinking this way, or you can challenge me. O3 dynamically is pointing to an object of type C1. I know that C1 right here has the method M1 defined. So this line, O3.M1, should compile. Let me say that once more, okay? Please listen carefully. I'm considering this line of method call. O3 dynamically right now is pointing to a C1 object. And C1, according to definition, has M1 defined. So this method call here, calling M1 on O3, should compile. True or false? Quite a good number of your fellow students from yesterday said true. If that can influence your decision. Guys, true or false? First of all, just true or false? What I just said is true or false? False. False? False? Oh, okay, you guys are good, right? What I just said there was deliberately trying to mislead you for good reason. What I just said over there might sound sensible to you because dynamically O3 is really pointing to C1. Why can I not call M1? Right? Huh? Yes, exactly, right? So guys, here is the thing, right? So again, what I just said over there, if you wrote it down, don't worry, don't erase it. What I just said there is a very common misconception about understanding, right? So here's how we think about it. When I look at O3.M1, yeah, there should be a parenthesis, by the way. There's a typo, okay? Should be a parenthesis. So when I say O3.M1, whether or not it should compile, I don't really care what it is pointing to. I only care about the static type of O3. That's the principle. All right? Does object declare M1? No. So this will not compile, first of all. All right? Guys, it's a very, very important concept. All right? So this line here, not compile. Because the static type of O3 is objects, which has whose expectation does not include does not include M1. All right, so similarly, O3.M2 also does not compile. So these two simply do not compile. Right, for the same reason. Okay. So now, let's now think about this. What I want to do now is about compilation. How can I make a compile? Basically, somehow I want to modify the static type. So somehow this static type here for objects is too restrictive because object expectation has only equals. I want to expand it to M1. Somehow I want to change from object into C1. That's what I want to do. All right. However, I cannot simply modify this one to be here to be C1. I cannot do it because it's static type. It can never be changed. So now here something will come into play called typecasting. What typecasting will do is I'm just going to create an alias that's going to point to the same objects as O3 is pointing to. But for that alias there, it's going to have the right expectation I want. Okay? So what I'm trying to do here is this. So I want you to look at this expression here. Let me visualize it, and then we'll try to look at it more closely. Okay, look at just this line right here. Okay, so O3 and then cast to C1. Okay, what does that do? It does two things. Number one, it's going to create an alias. So this alias over here. So this one here, this expression, okay, O3 and C1, is going to point to the same object. It's like an alias. That alias will have the static type just the same as what we are trying to cast into, which is C1. Okay. Once we get this alias over here with the right static type, we can now invoke the method on that typecast. So what we're doing is we're still calling M1 on the same object here. It's just about which reference variable we are using to really call that. If you use this reference variable O1 to call that, yes, because C1 has M1. But if you use O3 to call this method M1 on this object here, no, you cannot do it because object wouldn't allow it. But if you actually create this alias using typecast, it has the right static type. Yes, you can call that, right? Sounds tricky. Let me write it down. Okay, so important concept here. All right, let's now talk about this one here, okay? So if I have C1 and then O3, and then I say M1, all right? Let's now break it down, okay? Understand it, what's happening here. Let's start with O3. O3 itself simply got a declare type objects, right? O3, and then we know that it points to something right here of the dynamic type C1, right? I'm just repeating the diagram from the other page. That one there has just C1, all right? And then here, C1, O3, okay? Think about this. We are saying that casting O3 to C1. Another way to think about is creating an alias of O3 with static type C1. Right? This is what you will normally hear people talk about, casting O3 to C1. However, that one sounds a little bit misleading. It might sound like we are changing O3. No, we are not changing O3. Not really. So this might be a little bit better, more accurate understanding. What we're doing is we're not changing O3. Instead, we are creating an alias right here. The alias simply got C1 and also O3, right? That's an alias name. So this alias with the static type C1. So now through this alias, we will be able to call the method we want. Okay? One more thing. So object here, object over here, we have the expectation just equals. And C1 over here, we have the expectation M1 and also equals. In that way, we will be able to call M1. Just before I answer your question, just one more thing. Okay, I'll get to you. Okay. Let's now look at why do we have these two parentheses. That's also important. What if we didn't have it? The parentheses here forces the order of evaluation. If I simply got C1 and then O3 dot M1, what this means is something different. This one here is saying that make this method call and then cast the result to C1. This one here means cast that first and then call the method. Right? You can see the order of evaluation, right? And of course, this one here is not gonna compile, right? Okay, so this one here is going to force the cast to happen first before the method call. Question, please.
So let's say you cast it, and then the next line would be O3.getClass. Will it be object?
Very good question. Very good question. Let me make it clear. Let's say this. If I say O3 cast to C1, and then we say dot M1. Before this, we know that O3 has O3 static type is objects, right? Let's say after this method call, O3's static type remains to be object. Doesn't change. Because if you look at the diagram, you know what? I don't really need a new page. Let me just copy this. I'll put it here. Okay, right here. Okay. Let me do better. Right here. Because you can see that when I do the typecast right here, I'm only creating an alias. I'm not really modifying O3 itself. So even after the typecast, O3 remains to be of type objects statically. Question? Yeah.
So if we say O3 equals the casting, O3 equals C1, O3, will that change the type or no?
No, you wouldn't. Just remember, there's no way you can modify the static type of a particular variable. All you can do is create aliases of different static type. That's the way to go.
So when you reassign O3 to be the casted version, like C1 O3, is it pointing to the alias or is it different?
You mean the alias over here?
Yes.
Okay, so this alias here is definitely pointing to the same object as O3. The difference is O3 has a static type objects, but this alias here has a static type C1. That's the difference.
So if you did O3, can you do like O3 is equal to C1 O3?
O3 is equal to C1 O3. You can do that. However, it's not going to help. Okay, I tell you why. Okay, I can, since you ask, no problem. Okay, let's try. Okay, remember objects, and also we got O3, right? And at the moment, O3 is pointing to this object, right? So if I say object here, O3 is assigned C1 and also O3. Very good question. Let's think it logically. First of all, let's start with the right-hand side. C1 O3, as we said, is referring to this alias. Agree? That one there. Yeah. Okay? And then we're saying that O3 is not going to be reassigned to whatever object that's being pointed to by this alias. It's the same objects. So O3 wouldn't change. It's still pointing to the same objects. Yeah. So we're not doing any change. Yeah. Right? Good, good, good. But it's a good question. I can see the potential confusion. So this one here, not going to change where O3 is pointing to. Yeah, of course, you know, about variable, yeah. So about variable assignment, right, there's a certain rules which I didn't deliberately don't want to talk about just yet. It's going to be, take some explanation. We want to do it systematically. Yeah, okay? All right, so guys, let's now go back here very quickly. And then, so that's why these will compile. And then let's do one more thing, okay? Let's now do another one here. Let's say this one here. When I say O3 is assigned to O2, right here. So that one there is actually going to O3 rather than pointing to here. It's now going to point to this object here, right? That's what it would do. So now it's dynamically really pointing to C2, but doesn't really matter. All we care is about the static type. So that's why you can now cast O3 to C2, or cast O3 to C2. So that would mean this particular expression here, the typecast. So this is an alias with static type C2, right? And this one here is an alias with static type also C2, right? Because M1 is not part of the expectation for C2, so this is not going to compile. And this is okay. All right, similarly, just let's go back to before. This cast expression here has a static type C1. C1 has M1, so this is okay. On the other hand, which I didn't say, this one here, we know that has a static type C1. And C1 does not have M2 as the expectation, right? So that should be not compiling. So try to maybe review this example here line by line very carefully, right? It's so important to get it right. Okay, we got about 4 minutes. Let's do just a little bit more, okay? Let's do phase 3 quickly. Now we built all the foundation. Now we're good to talk about phase number 3. Okay, let's now talk about phase 3 here. And let's now do some very quick foundation check. If I'm able to reach this line, that means this guy here is false. And this guy here is also false, right? So that means this and OBJ not the same objects. And also OBJ is also not null. All right, very good. So now, what are we trying to do here? All right, let's see, okay? So this one here, let me just highlight it. Get class and also get class over here is going to return the dynamic type of the context objects. So this one here, return the dynamic type of the context objects. All right. And we are saying that if they are not equal to each other, if the dynamic type of two objects are different, that means we're comparing banana with apple. By definition, we cannot do it. Right? So this one here, not equal. Objects with different dynamic types are not equal to each other. Okay, let's visualize this a little bit, okay, quickly. Okay, so let's say we got this .get class. So this is pointing to some object over here, which has certain dynamic type. I'll get there, okay. And also we got OBJ right here. It also has some dynamic type. Let's say, for example, this could be triangle. You know, just make it symbolic. And this could be some star. All right. So now let's think about this guy here. Triangle is what you will get when you say this dot get class. The star over here is what you will get obj dot get class. In this case, they are not the same. So you're going to get return false. You cannot compare two objects of different dynamic types. Question?
Is there a way to make the actual class so that, let's say I'm doing another version of the string and another class called string, so I want to be for the user to be able to compare the normal string that comes with the Java with my own version. If I'm doing
Right, so if you really create your own version of string class, it's considered, well, to Java, they don't understand the meaning for the class, right? If you just create a new class, call that maybe myString, for example, it's just a different class.
Yes. What if I want to compare, can I, for example, check if the class is the primitive class, the primitive string, so that I can do the comparison myself, do the comparison of the characters myself?
I'm afraid you cannot. So the best you can do is once you define your myString class, you can just override the equals method to really say, when you got two myString objects, how would you compare the contents? That's how you would do it.
But you cannot say my string and a string?
You cannot say that because they are different dynamic types. They are different. Yeah, there's just no way to be around. All right. So guys, let's do one more thing. If you can give me 1 minute, I promise, just 1 minute. Okay. So we are now pretty much done, and I'll get to just this one here. Okay, let's get it done, and then we're good. So here we got the argument, which is a string, right? Right here. So that one is S pointing to a string objects right here. Okay. And then we talk about P1 and we talk about S. So P1 dynamically is this. So this is the dynamic type. And this is the dynamic type. Okay. If you try to trace the code, I'll leave exercise to you. You're going to get to this line right here. Okay. Just this line. And that way, when you say this.getClass, P1.getClass, point V2. Obj.getClass, S.getClass will be string. They're different, so this is going to return false. All right? So try to just do this last example here before Thursday. Okay? So this one here is going to return false. All right? Thank you so much, and good luck to you tomorrow, and I'll see you there.